Hello everyone, I'm Ravi Kumar Singh from TCS Research India. Today I will be talking about our work on re-architecting of an e-retail recommender system RecServe into HiServ. So that's the quick outline for next 5 minutes. Let's take a moment and let's see what's our motivation behind choosing this work. As customers interact with business, their engagement points evolve. This figure illustrates that organizations may utilize various recommendation systems of varying sophistication to enhance customer engagement. Essentially, business upgrade their recommendation systems by incorporating newer and more advanced models while phasing out outdated ones. It is also common for multiple recommender models to coexist concurrently. Therefore, a recommendations is typically a combination of several recommendation models working together. Let's talk about challenges while using multiple recommendation models, and it is also a common way to give recommendations to a customer, and it can be difficult because different models have different requirement, technology, architecture and data feature. This can affect how fast the recommendations are made and how many can be made at once. Our recommendation model can handle all such these challenges and give recommendations to customer quickly, accurately, even with lots of data. We exploit two different types of recommendation models in HiServ. First one is NiSer. NiSer is a real-time session-based recommendation model which predicts next likely products to be clicked or viewed using customer parts clicks in the current session, where the Light FM is a ML-based model which uses product features, customer product interaction features, customer features for learning the embeddings for customers and products. This model performs dot product over the learned customer embeddings and product embeddings and calculates the scores for every product corresponding to each category and customers and finally store them. Now, let's actually walk through HiServ architecture to understand its working. The offline model consists of three steps, namely O1, O2, O3. O1 is the data preparation step for Light FM model, which includes creating the data objects for inference, such as customer and product embeddings. In its O2 step, the Light FM model generates score for each customer product pair using dot product between their embeddings. In O3 step, the generated offline recommendations for each customer category tuples are to be stored accessed later and then merged with real-time recommendations. The real-time processing steps begin with R1, where the customer's ongoing session is fed to the nicer model along with asynchronous query message sent from the web server. In R2 step, the nicer model predicts the next set of products that customer might be interested in. In R3, the product recommendation list corresponding to each input session is inferred by nicer. In R4, the product list recommended by LightFM is accessed from the cache when asynchronous query message is received from the web server before completing R1, R2 and R3. In R5 step, the recommendation list of both Nicer and LightFM are merged to create the final recommendation list of product. This list is then provided to web server as shown in R6 step. In HiServ, we had to complete 6 real-time steps and 3 offline steps, and we encountered several challenges along the way. In this presentation, we will focus on the challenge we faced during step R3. If you want to learn more about other challenges, please refer to our paper. Let's discuss how we overcome the challenges in step R3, where the steps S1, S2, S3 performed by RecServ using product IDs are replaced by faster tensor-based operation using product index by F1 and F2 steps to make pipeline more faster. Let's discuss the results. First table provides an overview of techniques and technologies used by both RecServ and HiServ in various real-time and offline steps. Using better techniques ensured that the performance of HiServ was much better than RecServ. RecServ and HiServ uses different methods of processing data. RecServ uses data frame operations, while HiServ uses NumPy, tensor, and dictionary operations as well as batching. The next table shows the latency supported by HiServ is close to 65 milliseconds, which is roughly 23 times lesser than RecServ. The throughput of HiServ is close to 1500 requests per second. The graph is also representing the same info.